Hello everyone, welcome to the start of a new series from our Year 10 content. We are looking in this video series at probability. Now, a lot of the previous probability aspects we have covered in a lot of the videos from previous years, so I'm just going to jump once again straight into the new content. And one of the big ideas we are talking about today, which uses a lot of the concepts and strategies we learnt from last year's content with our two-way tables and Venn diagrams, we are looking at the idea of conditional probability. Now, this is a specific type of probability that involves these types of tables and Venn diagrams we've been looking at. Now, let's take ourselves back to this idea of a Venn diagram and just draw one here. And we're going to introduce, in doing this, some key concepts and essentially looking at some notation that we're going to be using in this course. Now, if you'd rather not go through all the explanation and backstory, please feel free to skip ahead. And if you want to just look at some questions, which we'll be looking at later. Now, consider a Venn diagram, and we had, for example, let's say this was students bringing devices to school. So here we have, for example, laptops on my first circle here, and I have my, let's say, phones, and my intersection point here is both. And my one outside, that's going to be neither. So we're just going to consider how we go about calculating some new types of probabilities here. And this is going to be quite a step up from what we've been doing so far. Now, what we are looking at, particularly in this video, the idea of conditional probability. So there is some kind of condition applied. We're applying a probability with some other element, with some other condition here. I'll show you what I mean by that in just a second. Now, previously, we've been looking at things like, our questions would be something like, for example, find the probability of students having laptops, or the probability of students having both, or all these other particular examples. Now, the type of questions we're going to be asking ourselves in this video series is some more complex probabilities. We're going to ask, for example, a typical question we'll encounter here is, for example, the probability that a student has a phone, I'll call this P, given they have a laptop. So probability of a phone given that they have a laptop. This particular notation here is very tricky when we try to apply this stuff. This is what we call an example of conditional probability. And the condition bit here that we're talking about is this given. There is a condition to my probability. I'm finding this thing, the probability of phones, but under the condition that the people also have laptops. So this part, our given, is my condition. It's like when a friend asks you to borrow something. So say your friend says, hey, can I borrow this basketball that you have? You'd say, yes, you can, on the condition that you give it back to me in a week. The same kind of ideas are going to be explored here when we look at conditional probability. Now, we need to consider what this thing actually means and how this is going to change our sample space in our probabilities. So typically, my probability is given by the number of desired outcomes as a fraction of the number of total outcomes. And previously, when we looked at this idea, we would just kind of say, okay, like, we would always look at these total outcomes. We'd say there are 12 total things here between these numbers, and we would just be picking off, like, okay, what's the probability of laptops? What's the probability of phones? But conditional probability changes our sample space. So changes this bit down the bottom. I'm actually going to write that point here. So conditional probability changes our sample space. Or in other words, our total outcomes. So let's explore this. Let's consider my Venn diagram here. So I'm asking the question, what's the probability that my students have phones given that they have laptops? Now, thinking about this, we want to consider a different type of group, a different type of sample space. So the total amount of students I'm measuring my probability of phones is going to be the space of the ones that have laptops. So I'm considering the students that have laptops. And from those, I'm picking out which ones have phones. Now, this is kind of tricky. I want to see, okay, what is the total amount of students that have laptops? So my new sample space is my students that own laptops. That's my condition here. And that sample space is going to be the 4 that own just laptops, as well as the 2 that own both. So this entire circle that I've shaded in this space, it's a total of 6 people. So my new sample space is going to be 6. And out of these 6, how many own phones? Well, my phones are in this section, but there's an important distinction to make, because I'm not looking at the 5 students that just have phones. I'm looking more specifically at the overlap, because these guys in here are the ones that have phones out of the ones that have laptops as well. So my probability, my conditional probability of phones given that they have laptops is going to be my condition, my given that they have laptops, is going to be 6. So my denominator here, that is my new total number of outcomes here. And the ones that have phones, but also have laptops, so out of that sample space of 6, how many also have phones? I'm going to be looking at just the intersecting overlapping point of 2. So I'm looking at 2 over 6, or I can simplify this to 1/3. Now let's take this example and look at what happens if we go the other way. So let's just copy paste this particular thing here. And I'll fix this up a little later. Sorry guys, this is glitching a little bit, but if I consider the previous info that I had, so I close this and I have my same information. So we said before that the probability, So this is question 1, for example. The probability of phones given the students have laptops, that was going to be the 6 students that have laptops. That's my new sample space, because remember, our conditional probability changes our sample space. And my students that have phones, given they have laptops, so the numerator is going to be the overlapping intersection of the 2 circles bit here. So that gives me this. Now let's see how this changes if we went the other way. So for question 2, for example, let's find the probability that students have laptops given students have phones. Let's go the other way and see how this changes our probability here. So I'm going to get rid of all these sections and we're going to start again. We're going to take a further examination into this. So the probability of students having laptops given they have phones. Now, given they have phones determines my new sample space. I'm looking at the students that have phones. Now, how many students have phones? Well, that's going to be the ones that have just phones and the ones that have both. So that's going to be, my new sample space is going to be my 5 and 2 together. So that is my 7 in total. So that's my new sample space or my condition. So I'm looking for students that have laptops on the condition that they have phones. So the condition determines the new sample space. So I have 7 of these here. And how many students from these ones that have phones also have laptops? Well, once again, that's going to be my intersection point here. These guys, these 2 that have both, they have laptops. And they satisfy this conditional probability. These are the students that have laptops in the whole space or set from this pink circle on my Venn diagram that have just phones, that have phones in total. So this condition determines my new sample space. Now, I'll split this up into 2 videos, but just to finish off, because we're wrestling with these ideas and it's a little tricky to get your head around when you're first doing it, I'm just going to consider, before we finish and go into some more examples in the next video, I'm just going to introduce you guys to some notation. So anytime we write conditional probabilities, so let's call this conditional probability notation. I'm going to write this thing. So the probability of an event A given an event B, that's the type of thing we've been looking at so far. This can be rewritten in a simpler way, because mathematicians, we like to come up with notation for things to make it easier to work with. We're going to be using this particular notation here, with a vertical line separating my particular outcomes here, A and B. And this vertical line translates to this word given. So we are looking for the probability of event A, given event B. So here, when we looked at, for example, the probability of students having laptops given they have phones, we can rewrite this as probability of laptops given is this line, this vertical line, given they have phones. And similarly up here, the probability of phones given that the students have a laptop is going to be the probability of a phone given they have a laptop. So the order here matters. And this second part here is our condition. That is our new sample space. That is the circle we drew, this pink circle we drew around my new sample space. So when we looked at, for example, laptops or phones given that they had a laptop, my entire space of students with laptops, this pink circle, is my new number of total outcomes we are measuring. And in the same way here, my 7 I had all together here, that is my new sample space or total outcomes. Because with the condition now, I'm narrowing down different parts of my probability. I'm no longer looking at this whole thing here where we looked at, okay, there's 12 probabilities here in total, and we just read off the diagram. Now we're doing something extra because our condition gives us a different sample space to consider. But hopefully this gives you guys a bit of an initial understanding as to how to work through these, and in the next video we'll spend some more time just drilling through some examples. But thank you so much for joining me, and I'll see you in the next videos.